Welcome again, everyone. Thanks for coming. Today I'm going to talk about platform engineering, a topic that I think we should all talk and think about more. We don't write, talk, speak about it enough in the community, which is I will talk about it for the next 45 minutes. My name is Sander from Knape. I'm a cloud engineer at Skyworkz. Skyworkz is where we are right now. We're a cloud consulting company helping companies to get the most out of the cloud. We believe that clouds can make our lives way, way easier. They're a solution to many different problems. And me personally, I'm very interested in building a platform in the cloud. And what exactly a platform is something, of course, that will come up in the next 45 minutes. First, I would like to go through a kind of a thought process with you, which is we're going to deploy an application to production in the cloud, of course. So let's imagine I have an application connected to a database, works on my machine, it always does, and we're going to get it into the cloud. Some additional context, let's say that we work for a big company, they're building something greenfield, they're selling something new, they have time, they have money.
Unlikely.
Very uncommon, but it happens. And our application is going to be the first of many. There will be hundreds, maybe dozens of applications. There will be dozens or maybe hundreds of developers working in this new greenfield project. So we want to do things right, a bit at least. So what do we need to build our application in the cloud? First of all, we need a cloud provider, or at least a runtime environment where my code can run. Also a place where my database can be spawned. And since we want to do things right, we want to do everything in code. So we need some infrastructure as code. We need to define our virtual machines or Docker images or Kubernetes cluster. We need to define our database. We might need to define a network. There's much more we need to define. But of course, we can write it in code. We can configure it, but then we still need to actually execute it. So for that, we need some CI/CD, some automation, preferably 3 accounts: testing, acceptance, production. A CI/CD process that first goes to testing, then acceptance, then production. For our infrastructure, but of course also for our application. And when we're there, we need some artifact management, because our application will be a deployable artifact at some point, deployed to different locations, and we need to store that somewhere. And when we store it, we might want to do some security scanning, especially recently there are a lot of vulnerabilities, so let's do this right from the beginning. Let's do some security scanning. And then our application is there, but of course it needs to know the host name of the database, the password, the username, all this dynamic configuration that will be different per environment. We also have some other virtual machines running that we need to provision. Maybe our CI server needs to be provisioned. So we need, I don't know, Puppet, Ansible, Chef, those kind of tools. We need that to get everything up and running. Secrets, part of configuration management, a subset, perhaps. Of course, secrets are handled differently always. To encrypt them, or maybe put them in a secret management store. So we need to figure out something for that. One more area. Monitoring, logging, metrics. We want to know the state of our environments, see if our database isn't dying, see if our application is still working, number of requests, latencies, we want to know everything. And of course, if something is actually going wrong, we need to be alerted. We want to be paged, we need a tool for alerting. We have a database, it might be relational. We need a schema for that. We might want to automate that whole process of getting the schema up and running, do rollbacks if it fails, etc., etc. And we might actually have some personalized data, but we also want to test our stuff in the other environments. So we need to anonymize it and get it into the other environments, for example. How much is this going to cost? We want to properly tag, label everything, make sure that we know what we're spending, and especially with all the other applications coming, make sure we know who is spending what, if they're actually getting the value out of their applications. I should have started with this maybe, but everything should be secure. Is everything encrypted at rest? Is everything encrypted on the road? Is everything done using TLS? We already mentioned the security scanning. Everything needs to be secure. And there's more. We didn't really talk about networking, storage, traceability, synthetic user monitoring. There's still a lot of other stuff going on. There's quite a bit going on around this one simple application that we want to host somewhere. In other words, software development is more than just writing a programming language. It's an open door, sorry, needs to be said. Software development is way, way more than that. And my statement here is you need a platform. You need a place, a location, not just a cloud provider, but way more than that, a place where you can actually put that application, get it up and running as quickly as you can, having all those other components that we're talking about up and running already for you. Lately I've been seeing people saying Kubernetes is a platform. I've been working with Kubernetes, it's not a platform. It does tick off some of the boxes, most of them not really good, to be honest. So Kubernetes isn't enough. You still need a lot of other stuff going on around Kubernetes to get all of those features that you want out of it. Platform engineering then is of course building such a platform. And I came up with a definition, which is the composition and integration of a set of processes, tools, and automation. So all those components I just mentioned, putting them together. And to build a coherent platform, meaning that it's going to be the same for every new application that you put in there. And the goal there is to empower developers, so they can easily build, maintain, and also operate their business logic, their features, because what they do is of interest to the business, and what we do is of interest to the developers. Yeah, the word easily is in there. Can you make it easy? I think you can make it pretty easy. We'll talk about that later. And also the word operate is in there. It is 2019. I do believe developers should own their applications in production. So the platform we're building is going to enable them to operate their applications in production as well. Yeah, so why? First of all, it's efficient. If every developer would need to set up all those components themselves, it would take a lot of time. And all the time spent on setting up all those components is time not spent on their actual business logic. And it's not really that simple yet. There was a nice quote in an article I read recently about the human scalability of DevOps. And the reality is that we're not there yet from a IT community perspective. All these tools, all these components I mentioned earlier, some of them can be enabled pretty easily by a cloud provider or by an external tool. But most of them still need some layering, some work on top of it to make it easy to use. So networking, observability, deployment, all these kind of things, it takes time. It's not hard, everyone can do it in theory. But yeah, if everyone is doing it themselves, then it takes a lot of time, and all the time adds up. So why not have a platform engineering team that does it once for you? Just an example, recently I needed to refactor some VPC stuff, and I needed to remind myself of all the components related to a VPC, so how you actually set up a VPC in AWS. And I made this image. The point is, a VPC it's not hard. It's way easier than it was before we had cloud providers, but it's also not trivial. And this is just one of those components. Yeah.
What does VPC stand for?
Oh, sorry, good question. VPC, that is the virtual
Private cloud.
in AWS. It's the network. Online.
The cloud is a network.
Yeah.
It's your address space.
If you work with it daily, you may easily forget what it actually means.
Yeah.
But yeah, there are a lot of components around it, and they all need to integrate with each other. And it's not hard. Every developer can do it, but yeah, it takes a lot of time to actually get it working and to actually understand how it works. This is just one of the dozens of components related to the platform. So yeah, you need some specific knowledge. Some might say operational knowledge. Sure, that's part of it. But you need specific knowledge about platform stuff. And I don't think that's bad. I think that's fine. In fact, if a development team uses event sourcing for their problem, to fix their problem, then they need to have a lot of specific knowledge about event sourcing. If you're a platform team, they need to have a lot of experience with building platforms, with the networking, with the monitoring and logging, etc., etc. So, if you look at development teams in general, they'll typically own a set of logically grouped applications. So if you build the search functionality for your web shop, then you will build applications surrounding that search functionality. They're all related, they're all logically grouped. If you're a platform team, you build applications for the platform. They're all related, they're all grouped together. And for most of them you need specific knowledge, but it's really no different from all the other development teams. So you really are just a development team, so it gets a different name, sure, but in the end it's really just software engineering, which means that the practices of software engineering also apply to platform engineering. Sure, you're doing something else. Sure, your customers are the other developers in your company, and your customers are not the customers of your company. That's what the developers are working for. But at the same time, if a development team builds a content management system for the web shop so that other people can put products on the website, they're also building a product or a platform for other people within the company. So it's really not that different from software engineering. It's just something more specific than writing a programming language. I'm talking about a platform team. Of course, it differs per company if you have a platform team or if you have just a few people in different teams taking the ownership of the platform. And with bigger companies, you may have multiple platform teams. You may have one platform team building something in AWS, another one building something in Google, and maybe there's a third one doing all the monitoring and logging, for example, and they should hopefully work together so that they have one central logging solution. But I'll just be talking about the platform team, but yeah, read it as those who have the responsibility of building a platform. Yeah, so a platform is a very broad thing. It can be built in many ways. The top one is the old way. You give me your code and I'll run it for you. It's old school, still happens. Still happens too much. And the other way is, here's a Git repository, here's a pipeline, this goes to production, do what you want. Good luck with it. That's of course more of the way I'm talking about, because then developers can get it into production themselves, they can own it, they can operate it, and the platform is there to help them get that done. So I'll be talking mainly about the second part. Cool, so today, there are 4 challenges I want to talk about. I've been in a platform team, I'm now also in a platform team. You might say that every cloud team is a platform team, just semantics. But I have some experience with it, and what I learned is that organizational scalability is more of a challenge than technical scalability. What that means is, I'll get back to that. Also, you're going to build an opinionated platform. Decisions have been made, tools have been picked, there are processes up and running, and some people might want to use a different tool, or they might want to use a different process. So you need to sell that opinionated platform. Next, you need to specify some contracts. What is ours? What is yours? Who owns what? And how can you actually use the platform? And what ways are there around how you can use the platform? And finally, let's not forget, you're building the platform for users, for people within the same company, probably. So don't forget to collaborate with them. So also some tips on how to do that. Cool. Protecting the platform for organizational scalability. One example I will keep coming back to is AWS Lambda. If you don't know it, it's a service where you can supply some code, and AWS will run it for you. You can write code in one of the languages it supports, and Lambda will handle the running it for you. They will handle scaling. You only pay for what you use. This is the service that started the whole serverless paradigm. Because I think they mentioned in one of their blog posts serverless, and then someone catched on that, and now we have serverless. And this is the service that started it. And Lambda has a set of different languages they support, also a set of versions per language. And of course, people have continuously been requesting more languages, because at some point Python 3.8 came out. I saw that Node.js 10 has been released half a year ago already, not supported yet. So people are continuously asking for more languages. But AWS has built something that doesn't really scale, because with every language they add, they have more versions to add, and to maintain, and to operate. I don't think they've ever removed a version yet. Not entirely sure.
Node 6 is deprecated.
Yeah, your old Node.
Yeah, they did, not just 4, right?
Node 6 is end of life.
Really? I think it's a screenshot like
Or Node 2 or 12, whatever.
Now it's 6.
Not just 6, there are no more security patches, end of the month, there are no more, cannot spin up new functions, and end of day, it's all gone.
Well, what was there before Node.js 6?
4?
And before that, there was something with a weird word. Anyway.
Yeah,
Points on my time.
Yeah.
Okay.
I'm not that old.
I don't want to rub it in, but they killed something, yeah.
Yeah, so it didn't scale because they continued to add more versions and more languages. So last year they came with custom runtimes, which is basically give us a runtime and we'll operate it for you. And there are now runtimes for PHP and for COBOL and for whatever there is. You can build whatever you want, maybe even more code. And this is really their way of making a more scalable platform, because now you don't need to wait for AWS to support a new language. You can now also operate or build your own runtime to be able to use your own language, the language you want to use. And really what I'm going to talk about is how you need to protect the platform, because there will be many people asking for a new language, and if you're working in a platform team, there will be many people asking for very specific features. And what you can start doing is having a lot of if statements in your platform, saying, oh, if it is this guy or if it is that team, then sure, they can do this, and otherwise you cannot do this. But again, that doesn't scale. So you need to figure out a way to build a platform in such a way that it can scale. So the more features you add, you don't need to add more people continuously. But also, of course, make your developers happy. It's like a constant balance you need to search for. So let's say that you add a new feature to your platform. I think there's one really important question that you need to ask yourself: how much support do I need to provide after I've delivered this feature? And if the answer is more than right now, then your platform doesn't scale, because you're going to add more features, more and more features. And the more features you add, the more support you will need to provide, and the more people you need to bring in. And if you have 200 developers and you have 8 platform engineers, that works. But if you have 400 developers, you don't want to work with 16 platform engineers. That doesn't work like that. So the answer to this really should be less, because you fix something or you make something easier, or at least equal. So we're providing something and they can just use it. And support here doesn't mean that we're not going to tell them how it works. Of course, you have documentation, workshops, working together to show how the platform works. But when people actually want to use it, they can just click on documentation, they can find examples, and figure out how it works, and they're not in that process. One big issue with platforms typically is toil. Defined by the SRE people as something that's automatable, and funny enough, something that scales as the service grows. So that's exactly what we want to prevent. Some examples of toil. Let's say that you have Git repositories and people want to have more Git repositories, and you need to create them for some reason. They need to wait for you. Same with CI/CD pipelines. Hey, you have a new service, I need a pipeline. Can you create it for me? Sure, let's do it. Running a load test from a laptop. Let's say you have a security token to connect to that load testing tool. And you cannot share the security token because of security reasons, of course. Then they need to come to you, hey, can you start my load test? And you're also a single point of failure. And putting secrets into a solution. Hey, my token has been updated for this external service I'm using. Can you please put it into the secret management solution? That doesn't scale. It will happen more and more, and as the more developers join, as the more microservices are put into your platform, it will only increase, and you won't really get anything done anymore. Of course, there's also the old school operational toil, pushing caches, removing servers, renewing XML licenses, etc., etc. It's part of a platform. This needs to happen, sure. But it's automatable, and it's pretty easy to automate this kind of stuff. So, automate it. Those who have been working in who works in a platform team, by the way? Is there anyone? Nice, cool. Has there been a situation where you were a bottleneck? Yeah. Yes.
Believe me. Who would say no?
All those things I just mentioned, you're a bottleneck because people are waiting for you. So if you have a platform team in your company and people are continuously waiting for the platform team to do stuff for you in order to get your stuff in production or to fix production, you're a bottleneck. And only through automation you can really get rid of that. Also, your platform team there are some platform engineers here, so your platform team will typically have a lot of smart people in it. Because the platform is pretty broad. It's going from networking to logging to all this kind of stuff. So you need to really be a generalist. You need to have some SRE knowledge, DevOps knowledge, operational knowledge. There's quite a bit of stuff going on. And if you let these people do all these boring small things, they will probably leave because they're not interested in doing that. They want to automate stuff, they want to build stuff, they want to build features. But funny enough, at the same time, you also need to stress. Operational teams typically work more in a Kanban way, just ticking off issues from top to bottom. And development teams typically work on Scrum team ways with sprints of 2 weeks, building features in those sprints. But if you're working in a Kanban way and people are constantly putting issues into your Kanban board because production is down or you need to flush your cache or whatever, then you're continuously blocking people and you are continuously involved in fixing production. So it can actually also lead to stress. So it goes 2 ways, and both ways aren't really nice. Of course, you want to be in that middle way of flow, where you just build features and you have to rest, you have to continuously do stress. So how to fix that? Self-service, that's what I call it at least. If you have a lot of stuff in code, the Git repositories, for example, if you have them in code, you can actually automate it because people can request a Git repository to code, for example. So going back to those previous examples, the Git repositories, you can have a big list of Git repositories, including who owns the Git repository, and then a CI job can actually create the Git repository for you. Terraform, for example, has a Git provider, GitHub, and also GitLab. So through Terraform, you can create Git repositories. And then you still have the auditability of who created it, why, attached to the ticket, etc. Same with CI/CD pipelines. These days, pretty much every tool, every CI tool has a way to define pipelines in code. So if someone needs a pipeline, just have them create the code in their own repository, where the service is, and it will automatically spin up the pipeline. That's pretty easy these days with GitLab and Circle CI, etc. The load tests, let's say there's a security token, you cannot share it. Just put that security token in your CI tool as a secret, so no one can see it, and people can run the load test from there, for example. And you're not involved at all. Secret management, that's always a tricky one because it's about security. I have seen though that if you isolate your solution, so if people can only access what they need to access, only their own applications and not other applications, then I've seen that security was fine with giving them read and write access to their own secrets. Because of course we're talking about a way where developers own production, they own their own services, meaning they also own their own secrets. So why not give them access to their own secrets? Because they are responsible for production anyways. And worst case, you need to build some solution that you can put secrets in there with some manual approval, but then give that manual approval to security and not to your own platform team. And then suddenly security is fine with having the developers do it themselves, because then they become the bottleneck. So, I'm still talking about scalability. Let's say a developer comes in Slack or in your room. He says, hey, I need some help with something. So feature X, and feature X has actually been documented, because we have documentation. So the first thing you ask is, did you check the docs for feature X? And then this is a happy path. So the developer says, I have checked it, but something is not documented about feature X. In reality, they will probably say, oh, do you have documentation? Or where is documentation, even worse. And then it will take a bit longer, but happens in a short example. So it's not documented, which can happen because documentation is often not up to date. And instead of giving an answer, what you do is you create a pull request where you actually add the documentation for that feature he needs. You can also walk up to him and sit together for 5 minutes and write the documentation that way. And then you give him the pull request, hey, does this answer your question? I get him a happy path, so maybe he says, yeah, if you change this and this, it makes more sense. Cool, sure, let's do it. And then you get the pull request merged and you have updated documentation at the same time. Maybe it took 5 minutes longer because he needed to wait for you to write out proper sentences instead of giving a quick answer in Slack. But once people get used to this, they will understand that this is how you work, and they are fine with waiting because they understand the bigger picture, which is that next time they can just go to the documentation. So they forget again how it works. Cool. So summarizing how to protect yourselves, automate, provide services, provide features as a service, so that they can do it themselves without you being in the middle. Also prefer managed solutions above self-hosted. We'll come back to this a bit later as well. But the point is, if you have a self-hosted solution, let's say a CI tool or a monitoring tool, every minute you spend on maintaining that, people already realize that spending 20 euros per month on your own service is cheaper than paying 500 euros per month on a managed solution. People understand these days that, of course, there's also the maintenance and setting it up that takes time and costs money. People get that, luckily. But what you shouldn't forget is that all the time you spend on that is time not spent on the actual platform. Because if you want to build a platform that's easy to use, you need to spend time on that. If you're in the meanwhile spinning off virtual machines, replicating clusters, whatever, then that's time not spent on the actual usability of the platform. Not saying to always use managed solutions, because they sometimes miss features or there are other good reasons to host them yourselves, but prefer managed solutions.
There's of course tons of companies who still work this way, and who don't even understand that. They seem to don't need to understand to change.
Yeah, exactly.
They'll die.
Are you working with these kinds of companies, or?
I do. Yeah.
And what happens?
Yeah.
Or then they probably work much more in some of the psychological part and the organization culture part.
Yeah. This is not technical at all.
No.
That's not the challenge.
Yeah.
Technical part, yeah, sure, you can do things in 100 different ways, but you pick one. But the challenge is about the organization, about the mindset.
Yeah.
And if you have an operations responsibility person, whatever, manager, who is very old school, I should change this. Then it's very hard.
Yeah.
And in my current situation, the person is like 3 or 4 levels above me, so it's very hard for me to change. So what I'm trying to do now is make small improvements as a service, and show as an example, hey, this is also how it can be done. And I hope that they realize that these other operations people, that they're thinking in the old school way, through examples, lead by example. That's what I try to do.
Yeah. And if you do it small, then management also doesn't complain about things that you're doing. You must do it, and then finally, if the manager realizes, hey, this works, then it's fine with me. But if you say, like, I need now 2 weeks to improve things, then he says no.
Yeah, show by doing. That's,
Manage your boss.
Yeah, so prefer documentation above single answers, point people to the documentation. Also to change the mindset of, oh yeah, we have documentation, also ensure that you keep it up to date. And keep it simple. That's the key way for people to use it. But we'll get back to that a bit as well. Yeah, opinionated, meaning we have made decisions for you. This is how you do it. You are blocked by our platform. That's how it can be perceived. Going back to Lambda. Lambda is super opinionated. It's super abstracted. It abstracts a lot away. So you are tied to these languages. If you want to use Node.js 0.12, yeah, you can't. Or if you want to use Node.js 10, you also can't. Of course, until they release custom runtimes, because now you can actually run with languages, which is a way to scale the platform. Talking about abstractions, if you look at the level of abstraction in building solutions, of course, at the bottom you have bricks or building your own data center. I don't think anyone's still looking at that. Then at some point you have IaaS, infrastructure as a service, so cloud providers, building your own VPCs, putting virtual machines in there. At some point you get to serverless. I have in quotes because everyone interprets it differently, but a high level of abstraction. At some point you have the platform, which is the platform you as a platform team are building for the company. And there are many different components we saw, and for every different component you're going to pick a different tool. And per tool it will differ how much that tool already does for you. So to give some examples, so what I mean is blue is managed by a tool externally, so not your worry. And the orange part is something you have to fill in because you have to actually build a platform that's easy to use. So to give some examples to make it more concrete. Splunk Cloud, AWS CloudWatch, Secrets Manager, Google Cloud Data Store, they're all fully managed, so there's not a lot you have to do. You can just start using it and it works. But at the same time, if you want to spin up a support vault, or you want to do Splunk self-hosted, we use Prometheus or Grafana for dashboarding. MySQL on these two, don't do it, but it can be done. Or GitLab on these two, then a small part is arranged for you, which is the virtual machine maybe and the network, and the data center below that. But you have to do the rest yourself, so there's a whole big orange gap to fill, and that's work you have to do. That's a abstraction you still have to add in order to make the platform easy for developers. I thought I removed the slide. Oh. I actually had a slide where the second from left was Terraform, and this was then CloudFormation, because in Terraform you still need to store the state somewhere, so you need to arrange that, and CloudFormation has done it for you. So you have to do a little bit less to get it working. That's a point I removed because my presentation is already getting too long, but now I still mention it. So orange is bad-ish, it means you have to do work, it means you have to add stuff to make the platform easy to use for developers. And blue is nice because you don't have to do anything. And the platform at the top, that's then the interface for developers. That's where they fetch, that's where they start using the platform. And in the case of Lambda, there are two ways, of course, to use it. Because one is give us a language, code in a language in a certain version, and we'll run it for you. And the other option is give us a runtime, and your code, and we'll run that for you. So there's like a lower abstraction there. So the platform isn't per se only usable at the highest abstraction, but you can also use the platform in lower abstractions. So in Lambda, if people say, I don't want to run this language, I want to run my own language, sure, you can do it. Here you go. Build your own custom runtime, and we'll still run it for you. But you have to be super clear here, because talking again about scalability, if you're going to help people with building their custom runtimes, you're still doing a lot of support. So document how to build custom runtimes, document how they're supposed to be built, but let them do it, because if you're going to help them with that as well, you're not going to have any time to do, you're not going to have time to do anything else. If they don't want to build a custom runtime, sure, we support some stuff, but if you want to go an abstraction lower, sure you can do it, but it's up to you. We cannot help you with that. To give some more examples, so Lambda versus Lambda runtimes. Let's say that you have a GitLab solution running on EC2, you maintain that, you operate that, but someone wants to use Jenkins per se, sure, you can also spin up your own virtual machine, but we're not going to help you with that. You need to write your own configuration management, you need to figure out yourself how to do the secrets, or you can use our secrets platform of course, but we're not going to help you with that, because we don't have time, because you want to use Jenkins, but he wants to use Circle CI, he wants to use something else. If we're going to help everyone with maintaining their own CI/CD server, for us that doesn't scale. Then we need to hire 10 more people. So get that knowledge into your own team, because you're going to need to run stuff on a virtual machine. You're going to need to apply security patches. Get that knowledge in your own team, so we cannot help you with that. Same with Docker or EC2 images. As a platform team, you can give them default EC2 machines, for example, EC2 images that are approved by security, because you run security checks, for example. But if someone wants to use a different image, they need to run security checks themselves. They need to approve it with security that they can use that image, for example. And we cannot help with that, because we don't have time. Same with the network. You can supply a network, and every application is running in that network. But if someone wants to, per se, build another network, sure, you can do it. We can even attach it to our network if it really needs to. But we're not going to explain to you how VPC works, because that's already documented by AWS. So get the knowledge into your own team. It's abstract, but if you want to scale as a platform team, if you want to get things done, then you need to be very strict. Another example of abstractions is I saw in Elasticsearch the cluster settings. There are 361 settings you can change. So if you spin up Elasticsearch yourself, there's a whole list of settings to go through to optimize it for your very specific need. Because what you're doing is special, of course.
Yeah, you're unique.
If you run Elasticsearch in AWS, actually version 6.5 was released yesterday. I don't know if it's been changed. But with version 6.4, there are 5 settings you can change. So out of those 361 settings in AWS, you can only change 5. So I'm sure they get support questions, hey, can you also make this one setting available, because we need to change it. You'll probably say, sure, we'll put it on the backlog, and there's +1. But for now, you can spin up Elasticsearch on EC2. And we're not going to help you with that, but you can do that. So there's an alternative. So again, make an opinionated platform, make it super easy to use your features of your platform, but also offer a way out. Because that's a way to say, what's the phrase again? No, but. So no, but there's an alternative. Instead of just a no. It's about balance. Of course, every feature you build, whether it's a secret management solution, you're using AWS Secrets Manager because you don't want to spin up reciprocal vault. But then there's a team saying we need vault because of reasons. We cannot do that. If every team in the company asks for it, then we can spin it up, because then the business value appears. And hopefully you have a set of POs, product owners, who are responsible for costs and prioritization. And then the PO needs to decide if there's business value for a certain feature or a change of tool to another tool. But in the end, this is the biggest challenge with building a platform. It's opinionated. People need to use it like that, or start doing stuff themselves. And in my opinion, but this is, I know people differ about this. To me, it doesn't make sense that a development team is spinning up their own CI/CD server when there already is one. To me, it doesn't make sense that they spin up their own monitoring solution or that they spin up their own network. I know it happens. I know very mature teams can do it, And for them it might make sense, sure, because I know that if you come into a company and you are super experienced with GitLab and the company is using Jenkins, then you as a person or as a team are moving slower because you need to get experience with the tool. So you are slower because of the platform, sure. But that's like a local optimization. But if you're with 200 people and now you're asking this one platform team to spin up a Jenkins server, maintain it, operate it, patch it, etc., then sure, you go faster, but the platform team is going slower. And also, because there are now 2 CI/CD servers, people can choose, sure. But at the same time, if you want to get an overview of what's running in your infrastructure, you need to go to 2 different CI tools. And let's say that someone wants to get some metrics on number of deployments. They need to get those metrics out of 2 different tools suddenly. So the more tools you have, especially if they solve the same problem, the more work it is. And then again, you're not scaling.
But the interesting question is, why does it happen that you have two solutions? Is it because teams just do it and there's no organization, management for it? Or if it's the other way, they have a completely freedom of choice. Because I see companies where this happens, but they actually don't have any of, they seem to not have any, nou, how do you say this in English?
Governance.
Lijkt dat ze er nauwelijks een visie op hebben, er nauwelijks een idee op hebben dat dat een goed idee is of geen goed idee.
Yeah, I think by having a vision from a platform perspective, a vision on how you want to build your platform, and making it super easy to use your platform, and people understanding why you chose a certain tool over another tool, and seeing how easy it is to just get running with your tool, then they will start using it. And they won't want to spin up their own stuff because it takes way more time. And hopefully a PO above it saying, yeah, this is a 40 story, this is a 2 story, let's do that one. So then it makes sense. And yeah, I think there are still platform teams who have a hard time saying no, and then you will have 2 tools. But then you're only making it harder for yourself. That's my opinion at least. I had some talks about this with other people, and I know people differ in this opinion. But to me, this is super interesting.
Yeah. This is the business value perspective.
Yeah.
Very good.
Cool. Yeah. So you're building an opinionated platform, but how do we make sure that the decisions you make are being used? I'm now in a different team. I'm also in a platform team now, and at the beginning we had a small brainstorm on how we want to do stuff as a team. And this is at the top of our team manifesto, saying that we do everything with developers, so we collaborate. So whenever there's a tool we need to deliver, we do it together with developers. Because then you already have the buy-in for one team at least. So there's at least one team who has the knowledge on how the tool works, and you can at least say to other people, hey, but this team likes it, they are happy with it. Of course you pick a few tools and you start experimenting with those tools, and then together with at least one team, and hopefully more teams, you start working on that tool. And immediately you have buy-in. And you also have other people who actually know how the tool works. So you can also point people to that team saying, hey, you want to use it, but that team has more knowledge about how to use it than we do. So please talk to them. So work together with developers. That's key. So summarizing, how to sell an opinionated platform. Make it simple, go for high level abstractions, but also offer a way out. But make it so easy that they don't want to go the other way. And at the same time, make people aware that you're looking for the balance. That's the biggest challenge here. Make them aware, and they at least understand the context. Document decisions you made, tell them why you went for one tool and not for another. Then they will at least understand. And hopefully they will agree that, yeah, in the bigger picture it makes sense, and I'm not going to spin up Jenkins because that's what I happen to know. And of course collaborate, build the features together with developers to get immediate buy-in. Cool. When did I start? Cool. I'm going to try to speed up a bit. Specifying contracts. So you have a opinionated platform, but how do you use it? So contracts is really about how do you use the platform, but also what do we take care of and what's your responsibility. Again, Lambda. Lambda is very clear. We run your code. So what you have to do is you have to write your code, and what we have to do is we run it for you. So it's very clear who does what. And of course, the way to use a platform is like the interface of the platform. So if you want to put a secret somewhere, then there's probably an API where you have to do this and this and this to get the secret in that tool, or a UI or whatever. So think about the interface. The interface is, your contract is your interface, because that's the way to communicate with the platform. In a perfect world, it's very clear who's responsible for the platform parts and who is responsible for the application, and it's very clear where the one stops and the one ends. Of course, in reality, there's a gray area because they overlap. If you use Splunk and you want to get your logs in Splunk, there's probably like a standard library somewhere built by a developer or built by a platform engineer that easily gets those logs to the correct Splunk instance with the URL, the token, etc. And all the developers are using that library because they only reuse code. But is that library then owned by the platform team, or is it owned by the developers? That's kind of the gray area. And that gray area, make it as small as you can, make it as clear as you can, that you know who's responsible for what, and then you have a contract, because you know exactly who does what, you know exactly how to combine the two. And of course the whole idea is to have ownership. It's not for blaming or something, but if there's something wrong, you know exactly who to go to, because it's very clear who owns what. So you can also more easily, if there's something wrong, you can easily see, oh, it's a platform, oh, it's the application. And of course I mentioned before that there's no difference between software engineering and software engineering, because these two components can also be two different microservices. If you have a order service consuming a product service for some reason, then the product service, which is an API hopefully, has a contract, it has an interface. If you go to this URL with this ID, you get the information about the product track. And those two services are probably using an artifact management tool, which also has a service. So again, platform engineering is just software engineering. There is an interface, there is a way to use the platform, to use the services. But it's really no different from microservices consuming other microservices owned by different teams.
Can I ask one thing about the contract?
Yeah.
Is there also any way to formalize it, or is it just an agreement written on paper in a Word document?
Did you see the rest of my presentation?
No.
Oh, I'm going to come back. Yes, we'll get there. Of course, you need to write documentation, how to use your platform to make sense, and of course keep it up to date by implementing it, incorporating it into your support method. But don't forget, that's the next slide. Don't forget you're using managed services, hopefully, and those managed services have written documentation on how to use the managed service. So going back to this image, the blue parts you don't need to document, because if you're using Splunk Cloud, you don't need to document how to write a query in Splunk. So point developers to the correct documentation to deviate the work you need to do, and also to make it clear to developers that if they need to know how to write a query, don't come to us. We just spawned or set up Cloud Splunk. But how to use it, yeah, we happen to know, sure, because we also use it. But please also talk to other developers. So in other words, you want to know who's responsible. And AWS did a pretty good job with that, with their shared responsibility model. So they make it super clear what they do, the data center, the hardware, etc. And they also make it super clear what you need to do. So if you spin up a virtual machine, you put a token in there, and you open up port 22 for the world. Someone gets into a machine, gets your token, and does stupid stuff with that. That's on you. AWS is not going to say, oh yeah, we're going to help you with that. Because they made it very clear what the contract is. So you know exactly what's your responsibility and what's AWS's responsibility. So do the same with your platform team. Make it super clear who does what. Some examples. From a platform perspective, you automate building Git repositories, going back to the previous example, and the development team creates Git repositories using that automation. So you may have Toolkit, or you may have used Terraform to create those Git repositories. That's on you, that's the platform feature. The developers use it. CI/CD, there are runners, there are workers, and of course, if there is a queue, then people need to wait. So you make sure that all the skills, that's the platform, for example. And of course, how the pipeline actually needs to run, that's the developers, because it's their pipeline, it's their application. And you provide CI/CD as a service. And you make sure that there is always data, for example. And that you have metrics, and that you can get an alert if there's something wrong there. Yeah, again, this is opinionated, but if you, as a platform team, provide a network, then you might do the network ACLs, which is which subnets can talk with each other. And then the developers, they define their security groups, which is per application. So saying, oh, this application can talk to me, and that application can talk to me. You might have a Kubernetes cluster up and running, hopefully managed, but you make sure the cluster is up and running, and developers build applications that they run. And of course, the example with logging and metrics agents on EC2. So as a platform team, you make sure that every default EC2 image has the Splunk agent installed, or Datadog agent, and the development teams, they ship those metrics or those logs to the correct UDP port, and that's on them. We make sure the UDP port is working. Just some examples to give you an idea. Of course, how you exactly implement the platform differs, so this may differ for you. Always test what you are responsible for. RMA is actually auto-scaling. If you have Datadog, then you can actually get an alert if something is wrong there. Take some time to get to know when to alert, for example, but it's possible. Is my Kubernetes cluster stable? Is the logging metrics agent operable? If you build a new default image, you can actually test that image before you ship it to the developers. So you can actually test something with that agent to see if it actually works before you push it to developers. And also make this transparent. Make sure that these dashboards are publicly visible, making it easier for developers to also see if there's something wrong with the platform. You of course often have these status pages on websites. As a platform team, you can also have a status page to show, hey, we are having problems with auto-scaling. We'll get back to you. Shift left, if you don't know the term, it means that if you look at software development from having an idea on the left to production on the right, then shift left basically says do as much as you can, as much testing, linting, checks, do as much on the left side, so closer to the development experience, the development workflow on your laptop, for example. Because the earlier you get feedback, the better. If you get feedback that there is a bug in production, that's more of an impact than if you already saw that on your laptop or in your editor because there was a red line or something. Going back to your question, Martin. I'm now working on a way to enable developers to easily spin up load tests. This is a simplified example on the left of how you can specify a load test. And on the bottom it says project name and test name. And I need to know those. Because then all the tests you run are in the same test. So you can actually compare previous tests. You have a history of tests. And two, I also do some reporting, so I actually say, this project, this test had these results. So I need to know those things. And Lazy-Leader, that's the tool I'm using, probably also needs to know them. Or it might use a random name, I'm not sure to be honest. So what you can do, on the right there's a contract, simplified of course. But in that contract I'm saying I need to know the project name and the test name. There's a regex allowing everything. You can make it more specific. You can even say your team name doesn't exist because you're checking some external resource for all the team names that are in your company. But if you do this as far as possible on the left, the earlier the developer gets feedback, the earlier he sees, oh, I forgot a property in my implementation. But the best thing is in your editor you get a message, hey, you forgot this. But the second best thing, and you need to do that anyway, is to check it in your PR. So if we're talking about automating everything, if we're talking about having CI/CD pipelines in your repository, having a load test in your repository, you can simply lint that and you can check it to see if it's up to par with what you expect from a platform perspective, or even from a tool perspective.
So the left side is better than the right side, right?
Yeah, in my opinion, yes, because it's more on the left. It's already in your editor.
Left, right.
Yeah. As you're typing, you already see that you're forgetting something.
Right.
Yeah, so if you forget the test name, you can say you must specify a test name. But pro tip, also point to the docs, because a developer might think, oh, I forgot the test name, but why do I need the test name? And then he comes to you, hey, I get this error, why do I need this test name? Then you need to provide support. So instead, just point to documentation and have an explanation there why it's needed, and they will typically understand because you do it for good reasons. Another example of codifying your contract again is, for example, having a test skeleton microservice. You can clone a example or a template or a skeleton microservice, or you can use a more advanced tool like Cookie Cutter, where you can also add some templating logic to the cloning that's done. Check it out if you're interested. But that default microservice can already have a unit test and an integration test. That's tools typically picked by developers, not by the platform team, but sure. It can write a log to Splunk, it can write a method to Datadog if you're using those tools. It can fetch a secret from your secret management solution. It already has a CI/CD pipeline in there that goes all the way to production. So they already have a world in production, for example. And they have a super clear contract in code of how to use the features in your platform. And then they have a working example. And then I would be surprised if they say, oh, but I really want to use this other tool, when they already have something working. And this is an example. It's a it's actually codifying your contract. Summarizing how to define your contracts. Be aware of the contract. Be aware that there's a difference between the platform and an application, or at least that there are two components that need to work together. And with everything you learn, try to minimize the gray area. So if there's knowledge, if there is a difference of opinion between a developer and a platform engineer, figure it out and then improve the documentation, improve the contract, do what you can to make that gray area smaller. Of course, codify the contract, so do it as early as possible, shift left, provide examples and blueprints, and also make sure that the company understands the interface to your team. So how do you work as a team? The example earlier about providing support through documentation is a way of working for your team. It's also an interface. And it takes a while for people to get used to it, maybe, sure. But it is how you work, and it does work really well, I think. So make sure that people know that, people understand that. Finally, collaboration. More of a summary, because we already saw a lot of collaboration. If you ask AWS Lambda to add a new language, they will put it in the bottom of the backlog probably, or they will do a +1 somewhere, and you won't hear anything again. But when people can walk to your platform team, they sometimes often expect you to fix it immediately. But that's not really collaboration, because you hopefully work with sprints, not with Kanban. You have features that you build, you deliver stuff every 2 weeks, so it gets on the backlog. So going back to the scalable support, people need to get this. It takes a while, but when they get this, things get way, way easier. I saw it happen. It took maybe a year even, or half a year, but it works. People start to understand why you do the things you do. We already talked about getting value, so collaboration is building stuff with developers. Never forget that you're building stuff for developers, they are your customers. When you build a website, you also don't build stuff that doesn't make sense to the customers. It's exactly the same with the platform team, because again, platform engineering is software engineering, and your customers are there, and you are building stuff for them. We already talked about telling people to go to another team. At some point I worked with AWS Cognito, which is a user management tool in AWS. I was doing that together with a development team because they wanted to use the tool. So we set it up together. I looked at what I needed to do from a platform perspective, and they looked primarily at how to use the service. And if it actually helped them, it did. At some point there was a second team saying, hey, I also want to use this Cognito. Does it fit my problem? And I told them, go to that other team because they know way more about it. I just did a little bit of stuff, but they actually did a lot of stuff with it and they're running it in production. So they are the experts on this tool. Go to them. So instead of you being the hub, you being the question hub for everything, at least everything related to the platform, and the platform is big, so you get a lot of questions. Instead, point them to other people, and you will get more knowledge hubs. Same with the event sourcing example. If there's a team doing event sourcing, they are the experts on that. And surely event sourcing runs in your platform. That doesn't mean that you are the expert. Of course, the platform team typically starts with building a foundation in the cloud provider. So then they know more about the cloud provider than the rest, because they have actually done stuff with it. And only later developers join to start using cloud provider. So in the beginning you are more of a user of the cloud platform, you know more about it. But as more developers start onboarding on the cloud platform, you'll also learn more about it. So make sure that people go to other teams, other people who also know a lot about that platform feature. Also, recently I had a power outage, I was on holiday, And what I did, I noticed what I did. It's, I think, what everyone does. You first check other rooms. Is it just where I'm sitting right now, or is my whole house having an issue? Then you check with the neighbors. Hey, is everyone here in the street having an issue, or is it just me? And if everyone is having issues, you probably check with the power company. Hey, we're having an issue. Do you know? Are you fixing it? It's the same with an application running in a platform. If an application has problems, typically they first go to the platform team saying, my application is down in production, help me. Well, they are responsible for production. But instead, show them that nothing is wrong with the platform, you have a status dashboard, everything is green, all the applications are working, the network is fine, because that's what you also often hear, is AWS having network issues. If they do, then all the other applications will be down as well, and half the world will be down. So I don't think so. I didn't check, but I don't think so. But show them that that's how it works. That they are just one out of maybe 200 applications in your platform, and just go to your other development teams first. Are they also having issues? Because they probably have dashboards as well. So check with them first. And if there's a platform issue, I can assure you here, we have a status dashboard, we would know. And if not, we'll fix it because then we missed something. So thanks for telling us. It's a mindset. So help them with gaining that mindset. So summarizing how to collaborate, teach them how a platform works, but in a scalable way. Provide documentation, sure, provide workshops, we didn't talk about it, but of course you need to provide some workshops to get people on board. Make sure that development teams talk with each other, you don't want to be a hub. And also make it clear how you work. What's the interface to your team, and how do you want to help people, and how do you believe that you can easily, in a scalable way, help the company. It's super important. Last slide. First off, you need a platform. That's my opinion. And someone should own it. Ownership is super important, otherwise you get all these gray areas. Make sure people know who owns the platform and what is the platform. Think about scale all the time. You're only with a small group. There are probably way more developers in your company than there are people working on the platform. So with everything you do, ask that question, am I going to increase my support when I deliver this, yes or no? Opinions are okay. You are building an opinionated platform, that's fine. Let's make sure people understand why you're doing it and why you're picking tools to give them a way out. Make sure they can also do it their own way, which is way harder, but maybe there's business value there, sure. Make sure there are contracts, specify them, make sure that it's super easy to interface with your platform from a technical perspective. But be super careful, because if people go that abstraction level lower, and they start building their own CI server on EC2, then you cannot help them with learning EC2 or learning Linux or learning Puppet or Chef or whatever. They need to do it themselves. They are going to own it in production in the end, so they need to get that knowledge into the team. And in theory, if a platform engineer is bored, he says, you know what, I'm going to join the team, I'm going to help them with that, and I'm going to do development work. In the meantime, I can share my knowledge with them. I mean, that's awesome, sure, that can happen. But that knowledge needs to be in that team, because they own production in the end. And of course, don't forget, you're building a platform for your users, so collaborate. You can sit in a room for 2 months, build a central monitoring solution, and then everyone will hate you because you built something incorrectly. I hope we all know by now that sprints are a way to get early feedback from your customers, to give demos every 2 months at least, to involve your customers into the journey of building your software, because they will also change opinions while you're building the software and while they see a running product. It's the same with your platform. Just involve your developers. Work with them. So that's my story. Thank you for listening. Any questions or comments or experiences or yes?
In your story, I get the impression you're mostly talking about semi-greenfield scenarios.
Yeah.
Where you as platform team can decide, okay, we're going to support Node.js, for example, and not Python. Do you have any experiences with bluefield scenarios where there have been applications which have been built over the course of 10 years, which you don't easily get rid of?
Yeah, I do. I was in the lucky position of doing something greenfield a few years ago. So that's my main experience, I have to be honest, that's my main experience. And even back then I talked to other companies and they were like, oh yeah, I also need this, I also want to do this, but I already am doing stuff. And now in the last few months, at least, I learned that it's way, way harder. Because if there's already something there, then it's a technical challenge of building something new next to it and then interface the existing applications with that new thing. That's a technical challenge. But the mindset, the organization, the people, that's really the bigger challenge. And the only thing I know I can do is lead by example. Start small. Start with a small thing. I mentioned I'm now working on a load testing solution as a service. That's one way of showing the company, hey, this is also how it can work. And developers will see they can do it completely themselves in an easy way. And I hope to then build a second feature and a third feature and a fourth feature. And at some point show people, oh, this is also how you can do operations. So small steps and lead by example. That's my current take on that. May differ in a few years. Other questions or comments? Any experiences with platform engineering that are the same or totally different? So yeah.
Maybe a nice example what we are struggling with. We have a monitoring solution with Elastic we are using, and
the 361 settings you can change in the cluster level.
we deploy it by ourselves. So we have to do a lot of maintenance on that. And now an interesting thing that's happening is that we have the feature in Elastic for creating alarms is very poor. So you have to start creating JSON codes by scratch to make an alarm. And so now we are at the point, where's the balance between what will be support to the teams, or we create our as a platform team the basic JSONs for alerting, and then and help the teams. Or maybe we want to move to another tool that gives a more UI feature to create very easily the monitors.
Yep.
So I think for me that's an example of balancing, because we have developers, so they like the code and they want to make it as specific for their own purpose. And on the other hand, when you have an easy UI for creating monitors, you have some limitations in what you can do, what you can configure with the UI, but it's much easier to learn.
Yeah, exactly. So they can use the UI, which is like a higher abstraction and is easier to use.
Yeah.
If you're not supporting a feature or setting in that UI, then they can ask you to add it, and you can do that. Or they can already do it through just directly writing JSON. Which has a higher learning curve, but yeah, then they can do it. So you have a way out. Yeah,
Yes.
That's nice. Yeah, cool.
So that's the balancing example.
Cool. Yeah. Beers and second talk. Yeah. Cool.
Yeah.
Thanks.
Thank you.